All right, so this is the second problem of the QHack 2023 Quantum Coding Challenges. As I mentioned before, I'm not going to go over the first problem because all we're being asked to do is implement a function that returns the sum of two numbers. So we'll start with this one in detail. So for this problem, what we're being asked is to implement the following circuit. It has two qubits, and we have to apply an RY gate with an angle of theta 0 to qubit 0, and an RY gate with an angle of theta 1 to qubit 1, and then perform measurements that gives us the probability distribution at the output. These angles are given to us in the form of an array. So let's go ahead and start coding this. So as always, we're going to import pennylane SQML, and from pennylane we're going to import the autographed version of NumPy as NP. All right, and then first let's create our array with the angles that are going to be given to us. These are given in the problem as inputs, so we can go here and take a look down here to the input we're given. So in one case we're given this two angles, so I'm just going to copy and paste that here, and then we're going to create our device for our circuit, right? So QML device default qubit, and since it's a 2-qubit circuit, we're going to define wires equal 2. Next, we create our Q node using that device and define the function that is going to have our circuit with the gates we're applying, and we're gonna pass this angles to it, which is going to have what we need to apply to each of these gates, or what we need to pass to each of the gates that perform the rotation. And then we just do QML RY to apply one of the RY gates, and we specify the angle. So it's going to be angles 0 for the one that's going to go on qubit 0, right? And then wires 0. And then for the second one, it's just going to be angles 1, which is the second item on this list, and then apply to wires 1. And then since we are being asked to give the probability distribution, so what we do here is we return QML probs, and we have to do it on both wires. So we do wires 0, 1, right? Now, what we can do next is draw our circuit. So we do QML draw, and we pass our circuit, and then this QML draw, as I've explained before in a previous video, returns a function, and to that function we have to pass the angles, and then we can also print the output, which is what we're being asked to return. So we're going to do again circuit angles, right? If we run this, we can see our circuit here, in which we have an RY gate where we are applying that first angle to qubit 0, and then that second angle to qubit 1, and then this is the probability distribution we get for measuring state 0, 0, 0, 1, 1, 0, and 1, 1. And we can go and verify that this matches the result here that the grader is going to compare our output with. So we can see that we have obtained the correct answer. All right, so that's it for this problem. Hope to see you in the next one.